As a child, you might have imagined ways to surpass the speed of light, like using a large gear to drive a smaller one. If the first gear, 1 meter in diameter, rotates once per second, the second gear could rotate 100 times per second. Adding just 5 more gears might seem like it would make the fifth gear exceed the speed of light. However, the problem is that moving the first gear would require more energy than the entire universe has, making it impossible. Another relatively simple method is to use a very long rod, say 1 light year long. If you hold one end and give it a slight shake, wouldn't the other end easily exceed the speed of light? But in reality, the transmission of force requires speed. Even if the rod is made of diamond, it will deform under the force, and the other end can never exceed the speed of light. Some might say, why not make a rod that doesn't deform? A non-deformable object is known as a rigid body. To keep its particles from shifting, an infinitely large force is required, which might only exist between 2 black holes. While making a rod from black holes could be possible, that's a whole different realm. Here's a simple way to surpass the speed of light at home. I drive a yellow car, and you drive a red car. We start from the same spot and turn on our headlights simultaneously. You drive forward while I stay still. The speed of the light you emit would be the speed of your car plus the speed of light, making your light faster than mine. So, why do people say the speed of light is insurmountable? Let's look at another interesting phenomenon. If you tap the like button with your left hand will be 0.00000000000000000000056 seconds younger than your right hand after tapping. Although it's hard to notice, it really happens. You can try it yourself because space and time in our universe exist relatively. Objects can move only in time without moving in space, like a stationary car or you watching this video. Even if you're not moving in space, time is still passing. If the stationary car starts moving, it moves in both time and space. The faster it moves in space, the slower it moves in time. At a certain speed, time can even stand still. In fact, no matter how fast you drive, even close to the speed of light, the light you emit won't surpass mine. Because photons have no mass and no inertia, they won't be pushed forward by you. So, for an observer, the light we emit at the start will be 299,792,458 meters away from the initial position after 1 second, which is 1 light second. Now, here's the question. I see my light traveling forward at the speed of light from inside my car, and you see your light traveling forward at the same speed from inside your car, with the surroundings rapidly receding. For both of us, the light travels forward at the speed of light, so after 1 second, the length of the light we emit should be 299,792,458 meters. But why does your 299,792,458 meters seem shorter than mine? As mentioned earlier, the faster an object moves, the slower time passes. When 1 second passes inside my car, my light travels 1 light second. But because you're moving faster, you haven't completed 1 second yet, and your light has traveled less than 1 light second. So, the light beam seen by an observer is actually the length emitted by your car in less than 1 second. This explains why your light beam appears shorter, but from my perspective, your perspective, or the observer's perspective, we all agree that the speed of light is 299,792,458 meters per second. This is the theory of the constancy of the speed of light in Einstein's theory of relativity. So, using the method of driving with headlights on can't surpass the speed of light either. But let's imagine, if you could drive at the speed of light, what would you experience? The Andromeda Galaxy is 2.5 million light-years away, but that doesn't mean it would take you 2.5 million years to get there at light speed. Once you reach the speed of light, travel time becomes 0. You'd arrive at Andromeda as young as you are now, but upon returning, 5 million years would have passed on Earth. Interestingly, your left hand would still be younger than your right, so use your right hand to insert coins to keep them equally aged. But why is the speed of light exactly 299,792,458 meters per second? Why isn't the speed of light 100,000 meters per second, 1 billion meters per second, or even 10 meters per second? No one knows, but the question is intriguing. Maybe curiosity is in our DNA. For instance, our quest to find life beyond Earth led us to develop ion engines, invent Hall thrusters, deploy solar sails, leave footprints on the Moon, reach Mars, and exit the solar system. By solving problems, we advance technology and improve our living standards.